So in this video, I'm going to talk about using the integral test for series. So I'm going to do these two examples. So, okay, I think I'll just jump right into it and then I'll talk a little bit more about the integral test. So let's start with this series here. So I've got e to the negative 2n. Okay, so the integral test says that you have a sequence of positive terms, and then we want to suppose, so we let our sequence equal f of m, so we want to pretend it's a function. So pretend that this function is, so we want to know that it's positive, continuous, and a decreasing function. So this has to be true for all x greater than some integer n. I'll talk more about this in another example because this is going to be important. So then either the series and this integral, they either both converge or they both diverge. Okay, so with this particular series, so if I just think of like a few terms, so I've got 1 over e squared, and then I'll have 1 over e to the 4th, and then I'll have 1 over e to the 6th. So these are positive and continuous, and they are decreasing. So with each fraction, the number gets smaller, right? So that fulfills the integral test conditions, and so we can just set this up. So let's go ahead and set up the integral 1 to infinity e to the negative 2n. Actually, we'll make it all in terms of x, sorry. So we can just evaluate this integral. Okay, so I'm going to need to rewrite this with the limit as b goes to infinity. So I'll evaluate this integral here. Now this is a pretty standard integral to evaluate. So this will just be, let's see, negative 1 over 2 e to the negative 2x, and then from 1 to b. Okay, so if I plug in my limits of integration, let's rewrite this as e to the 2b, so I'll just rewrite it in its fractional form, and then plus 1 over 2 e to the just 2. Okay, so I wanted to just set up the definite integral so I could see what's going on here, so I'll make a little space and then we'll set up the limit. Okay, so now I'm going to take the limit as b goes to infinity of 1 over 2e to the 2b, and don't forget that's negative, and then 1 over 2e squared. Okay, so this is going to go to 0 because b is in the denominator. So this whole thing equals 1 over 2e squared. And so the conclusion here then is that the integral converged, therefore our series converges. And it will be bounded by this number here. Okay, so now let's look at a slightly trickier example. Okay, so I've got n squared over e to the n cubed. Okay, so like when you look at this, so if I just like write out a few terms, like it's a little confusing. Like, is this increasing? Is this decreasing? It's like kind of hard to tell, I think, when you first look at this, like what's going on here. So we can use what we know about derivatives to help us figure this out. So let me clear some space. So let's let f of x equal x squared over e to the x over 3. So what is the derivative? So now you've got to put your old Calc 1 hat on here. So this will be 2x e to the x over 3, so I'm using the quotient rule here, minus x squared times 1/3 e to the x over 3, and then all of that over e to the x over 3 squared. So let's see, what is that going to give me? So I've actually got to do some work here. 1/3 x squared e to the x over 3. So actually, what I notice is that all of these have a x over 3 in the top, so I can actually decrease this exponent by 1. So let me clear some space. So my derivative will simplify to 2x minus 1/3 x squared over e to the x cubed. Okay, so let's see, what can I do with this? Let's multiply the top and bottom by 3 so that I can get rid of the fraction. So I multiply the top and bottom by 3. And then that will allow me to rewrite the top as x times 6 minus x over 3e to the x over 3. Okay, so why am I doing this? Okay, so remember this is the derivative, right? This is the first derivative. And what does the first derivative tell us? It tells us when the function is increasing and decreasing. Remember that? So how can I determine where this is increasing or decreasing? Well, to do that, let me clear some space. To do that, I need to know the critical points. Remember all that good stuff once upon a time that you learned? So my critical points would be either where the numerator equals 0 or where the denominator is 0. So there's no place where the denominator will be 0, so I could just have these two points as my critical points, 0 and 6. Okay, so so what I need to know then, and let's see, my original domain is also all real numbers. Okay, so let's take a look at the interval and if f prime is positive or negative. Okay, so I've got all real numbers. It's my interval. And I just want to figure out for a minute what is going on with this function, because I actually can't tell just by looking at it if it's increasing or decreasing. So I know this seems like overkill, but like if you don't know, you might have to do this. Okay, so if I plug a negative number into this, so what's that going to give me? If I plug a negative number into this, this will be negative and this will be positive. So this will ultimately end up being something negative. If I choose something between 0 and 6, so this will be positive, this will also be positive, so this whole thing will be positive. And then finally, if I choose something over 6, let's see, if I choose something over 6, this will be positive and this will be negative. And this will be negative. Okay, so I did this for a general function x, just to remind you of the Calc 1, but let's remind ourselves what were we doing. So the integral test. So remember, this is a sequence, so we have to have positive terms, and we just need to know, so where is this function continuous and decreasing? And we have to know that for all x over some integer n. Okay, so to my point then, so first of all, we don't care about so in Calc 1 we cared about this, but now thinking about the language of series, our series is never going to end up going to negative infinity. So I just did that just to kind of remind you, but we don't actually need that. This is the information right here that we actually need. And I want to know then at what point is this decreasing? And it's decreasing after 6. So at 6, this equals 0. So we don't want to include 6. So for all x's over 6, this will be decreasing. So if I want to know at what integer is it definitely decreasing, for x's greater than or equal to 7. Okay, so this matters because if we go back to the integral test, this is where we have to start our integral at 7. Okay, so all right, let's go back to the original problem. And now I can go ahead and evaluate this integral from 7 to infinity. Okay, now I just have to integrate this. So I know it was like, oh my god, I just did all that work for taking the derivative and now we still have to take the integral. Math is really fun sometimes. So now to integrate this, I'm going to have to use integration by parts. So let's see. I will set my u equal to x squared. I will set my dv equal to e to the negative. So notice I rewrote this as e to the negative x thirds. So then this will be, let's see, this will be negative, actually this will be negative 3 e to the negative x over 3. And then my du will be 2x dx. Okay, so now I can go ahead and take my uv. So that's negative 3x squared e to the negative x over 3 minus my v du. So minus negative 3, so this will actually turn into a plus. And then let's see, I've got 3 times 2, so this will be 6x e to the negative x over 3. Sorry if you can hear my dog barking. She is defending the house, as she does. Okay, so now I've turned everything into an indefinite integral just for a minute so that I can just get the problem done, and then we'll get back to the definite integral. I won't forget, hopefully. Okay, so next, let's do it again. So now my u will be 6x. My dv will be the same thing. Okay, so then my du is 6, and my v is once again negative 3e to the negative x over 3. Okay, need more space, so let's do it. Okay, so pressing on. I've got negative 3x squared e to the negative x over 3, so that's what we had. Now we're doing integration by parts again. So let's see, my uv, let's see, that'll become negative 18x e to the negative x over 3 minus my v du. So I've got minus this negative 3, so this will actually turn into a plus v du. So this will be plus 18 e to the negative x over 3 dx. And now we've done it, right? So I can actually just straight up integrate this. So this will be negative 3x squared e to the negative x over 3 minus 18 e to the negative x over 3. And then this will be minus, so 18 times 3 is 54 e to the negative x over 3. Oh my goodness, I forgot an x here. All right, good times. All right, so now that we have that, I swear to God, sometimes like you do this and you're like, I'm done, right? And then it's like, oh, Jesus, we're like, no, we're close. All right, so we still have the integral test, right? So I have to figure out whether this converges or diverges. I'm mentioning this because I feel like, you know, I have that memory of a hamster problem, right? So sometimes I'm like, all right, cool, we're done. And then I'm like, oh, wait, no, we're not. Okay, so continuing on. More space. Okay, so here's my result, and here's what I'm going to do. So I'm actually just going to fudge this for a moment and put my limits of integration here. So I know that I need to evaluate the limit as b approaches infinity. I'm just going to write it right there, and then I'll go ahead and set this up. So I've got the limit as b approaches infinity. Okay, so I'm going to rewrite all of these as fractions now. So this is negative 3 b squared over e. Actually, you know what? I can actually factor out. Let's do it like this. E to the b over 3. I'm going to factor that out of everything. And then this will be negative 3b squared minus 18b minus 54. Okay, so there's one set of things. And then this will be minus 1 over e to the 7 over 3. And then this will be negative 3 times 49 minus 18 times 7 minus 54. All right, fam, so what's going on with this? So this will end up going to 0, but remember this part is in the numerator, so we've got to worry about whether this is, we've got a convergence issue here. Okay, so let's just focus for a minute on really this part of the equation. So I've got the limit as b approaches infinity of negative 3b squared minus 18b over e to the b over 3. So this gives me an infinity over infinity type problem. So I can use L'Hopital's rule. So let me clear some space. So in taking the derivative, so this will be negative 6b minus 18 over 1/3 e to the b over 3. And I still get infinity over infinity, so let's do it again. So I take another derivative. So I get -6 over 1/9 e to the b over 3. Okay, and so this whole thing will just end up going to 0 because this is growing exponentially. This is the only place where I've got a b, so this whole thing equals 0. So cool. So going back to this part of the equation, let's see, actually I'll clear some space. So this part of the equation is all going to 0, so then what am I left with? I am left with -54. Actually, so the whole thing will just, this whole thing goes to 0, so then I'm just left with 1 over e to the 7 over 3. And what does all this stuff work out to? All of this will work out to -327. So then I'm just left with 327 over e to the 7/3. But we're still not done. So this tells me then that the integral converges. And so then, to go back to the original problem, since the integral converges, this also will eventually converge. Or more specifically, we can really say that n equals 7 to infinity of this sum. This is the part that converges, and then you would just add the other terms in this. So if you knew where this converges, you would have this plus the previous terms from n equals 1 to 6. But there you go. So we can just say that this converges. All right, well, that was kind of a doozy, but hopefully that was helpful. I'll catch you guys in another video. Thanks for watching.